We have one more problem to solve, and this one is going to be a little bit different also, because in this particular problem, as you can see, we don't have a Ka, we have instead a Kb, and you can probably assume what that means. Kb means that our reactant, CH3, CH2, NH2, it is a base instead of an acid. Now that doesn't mean that we're going to change our strategy for solving this problem. We're still going to do the same thing. The first thing that we need to do is write a balanced equation. Whether it's an acid or a base, one of our reactants is the molecule in the problem, CH3, CH2, NH2, and always reacting with water, H2O. Now here is where things get a little bit different. When it's a base, instead of an acid, we are making OH minus instead of making H3O plus. I've got to get this stuff out of the way. So instead of H3O plus as one of our products, we have OH minus as one of our products. And where did that OH minus come from? It came from water moving one of its hydrogens over to the base. So that helps us predict the product, the second product, CH3, CH2, NH3 plus. And like I said on the last video, if you never quite figure out those products, it's going to be okay. It's not going to keep you from getting the answer right. So the next thing we want to do is make an ice table using the concentration that we were given in the problem. It says we have 1.25 molar CH3, CH2, NH2. We don't have any products yet. We don't know how much of that base is going to react, so our change is minus x. And because our stoichiometry is 1 to 1 to 1, minus x means we have plus x and plus x on the product side. And at equilibrium, we have 1.25 minus x, and we're still assuming that x is really small, so it's just 1.25. And our other products are x and x. Next up is to write an equilibrium expression. Be careful, this is a Kb, not a Ka. Our products are OH minus and CH3, CH2, NH3 plus, and that is going to be over CH3, CH2, and H2. And we're going to plug in the numbers that we have from the problem. We know that Kb is 6.46 times 10 to the negative 4. We know that we're using X for OH minus and CH3, CH2, NH2. And our reactant is 1.25. So now we just need to solve for X. Getting the calculator out, we have 1.25 times 6.46 times 10 to the minus 4. And we're going to take the square root of that. X is 0.0284. Before we get going too far on that, let's take a look at what X represents. X represents our OH minus concentration, which means that we can't directly use it to calculate a pH, but we can use it to calculate a pOH. Negative log of 0.0284. The pOH of this solution is 1.55. And since we know that pH plus pOH equals 14, we can use that to figure out the pH of this solution is 12.45.